Am I audible to you all? Okay. Good evening, everyone. I am Mohanapriya S, and it's my pleasure to welcome you all to this enlightening session on decrypting cloud security using AWS, organized by AWS Cloud Club, St. Joseph's Group of Institutions, in collaboration with PEP Cloud Computing and DevOps Center. Today, we are honored to have Jefferson, a dedicated and enthusiastic student from second year CSE from our PEP, as our speaker. With a keen interest in cloud technologies and a strong foundation in AWS, Jefferson will unravel the complexities of cloud security and guide us through the essentials of protecting data and applications in the cloud. This session will cover the key aspects of cloud security, including managing identity and access, ensuring compliance, and leveraging AWS security services to safeguard your infrastructure. Jefferson will also share a practical insight and best practices to fortify our cloud environment. By the end of this session, you will have a solid understanding of how to implement and maintain robust security measures within AWS, prepare you to tackle real world challenges in cloud computing. Without further ado, please join me in giving a warm welcome to Jefferson, who will lead us through this captivating journey into the realm of cloud security. Jefferson, the stage is yours.
Good evening, everybody. Am I audible?
Yeah, you are audible, Jefferson.
So, screen visible to you.
Yeah, your screen is also visible, Jefferson.
So, good evening, everybody. I am Jefferson Godfrey from St. Joseph's Institute of Technology. I am here to explain you about the topic decrypting cloud security using AWS. So that's basically just cloud security, and I'll be explaining how cloud security plays a major role in cloud and some AWS services which is based on cloud security. So first, we'll be looking at the overviews of the topics which we are going to cover today. First, we'll be looking as usual about the what is cloud computing and about the cloud computing aspects and the importance of cloud computing, the different types of cloud computing, is important in cloud computing. So, am I audible to everybody? Can you hear me?
Yes, Jefferson. It would be better if you raise
Okay.
your volume a little bit.
Okay. So, first, we'll be covering about the introduction of cloud computing. Then we'll be moving on to the importance of security in, and we'll be looking about the definition of cloud security and how cloud security plays a major role in safeguarding the practices in cloud. Then we'll be moving on to traditional versus cloud-based security approaches. We'll be looking at the traditional approaches and the limitations of traditional approaches and how the cloud-based security approaches overcomes the limitations that are present in the traditional approaches. Then we'll be seeing the common cloud security threats, the threats which we face, which is why we need security to prevent us from such threats. And then we'll be moving on to the AWS security services, which is used to protect us from these threats that we face. Then we'll be looking at best practices, general best practices which we should follow to ensure security in cloud service, and also AWS based best practices which we could implement ourselves while working on in our console. So, can anyone just unmute and tell me what is cloud computing based on your view? Any student?
So it is the on-demand delivery of IT resources such as databases, storage.
Okay.
Yeah. So, as he said, we often say that cloud computing is just storage, and we'll be specifying it to certain limitations. But that's not how cloud computing. It's not to a fixed limit. It is expanding day by day and developing day by day. So, cloud computing is the on-demand delivery of cloud power, database, storage, applications, and other IT resources via internet with pay-as-you-go pricing. So this is the definition which we would have learned usually since when we joined the cloud. I guess everyone would be familiar with this. And we can also we also know that while doing our POCs and tasks, I think many of you here have done the 30 days cloud challenge. We also have done certain chatbots using the AWS services, which means that there are certain facilities in cloud computing other than the ones mentioned here. We can also create a AI-based chatbot to get the output for the input which we give. And also we can also give the input text, and also we can translate the text which we provided. And we also have a voiceovers which we could use of our own. Then some of the benefits of cloud computing are scalability, cost efficiency, flexibility, elasticity, managed infrastructure, and agility. So specifically looking into scalability, scalability is an important feature which is why cloud computing and especially AWS is preferred mostly among major cloud providers. Scalability means keeping up with the upcoming demand and developing as per day-to-day need. So, if you are looking at cloud computing, basically we'd be divided into two types: vertical level and horizontal level of scalability. So, the vertical level focuses on adding more power to existing instances like CPU or memory, and horizontal scalability focuses on adding more instances or servers to distribute the load. We'll be just looking at an example so that you will be familiar with this. For example, everyone are familiar with EC2 instance, right? So the vertical scalability in EC2 instance means like improving the storage capacity or RAM capacity so that we can keep up with the upcoming demand in EC2 instance. But looking at the horizontal scalability, it is not just improving the storage, it is improving the number of EC2 instance on load balancer to handle the increasing traffic or demand. So that's the difference between vertical scaling and horizontal scaling. Are you clear with it, or anyone have any doubt? Should I explain again? Are you clear with it?
Yes, we can keep going.
Hello? Okay, thank you. So then cost efficiency. We also know that major cloud providers are always cost efficient because cost efficiency is easy in this major public cloud like platforms because there are millions of users worldwide, and even with a minimum price, the cloud providers would get a large amount of profit. And flexibility means the ability to adapt based on our needs. Like we'll be when we are, for example, when we are opening an EC2 instance, they'll be asking which type of instance you need and what are the specifications which we need. So it's flexible and we could choose it of our own. Then elasticity, just like we know, elasticity means when the demand is on, it would be providing us what we need, and when the demand is off, it would be going back to its normal position. That's how the basic definition of elasticity works too. It's similar here too. When we need the amount of EC2 instances more, we'd be getting more with the load balancer, and when it's not necessary much, it will be going back to its normal position so that cloud can be optimized easily, and we could, it is so elastic, so it is easy for us. Then managed infrastructure. So we all know that the AWS infrastructure is managed worldwide, splitting it up into different data centers, regions, availability zones, and all those. So we also have different people working behind this to maintain this and take care of the data so that our data is stored securely. And also the other benefit of cloud computing is agility. And the basic types of cloud computing. Actually, these are the topics which we know already, but still I'm explaining this again so that we could go from the beginning. So that major three types of cloud computing are public, private, and hybrid cloud. So public cloud is what we see in our major cloud providers like AWS, Azure, or Google Cloud platforms. Public cloud is not something so that the data could be kept in private, because in public cloud our data is visible to everybody, but we'll be getting more amount of features and we'll be having different levels of organizations and levels in which we could work through. But in private cloud works on the basis in which even an individual can create it. Individual or an individual organization can make a private cloud by setting up virtual servers or servers of their own and creating a data center of their own. In this, the data which they upload are private and limited to the organization or the individual itself. And it's not to the overall community or an outsider or an unauthorized person is not accessible to it. So that's the advantage in private cloud. But public cloud is far more advanced and has many features than the private cloud. But if you are looking at hybrid cloud, which includes both private and public cloud, a hybrid cloud would be having the advantages, especially the advantages of private cloud and public cloud. So while having the advantages alone of both of these, private cloud is of course effective. So it is important in maintaining our privacy. In hybrid cloud, we could also maintain our privacy better, and also we'll be having the features of public cloud so that it is cost effective on the same time too. Before going into cloud security, can anyone give a simple definition about or on your point of view about what cloud security is? What do you think cloud security is? Audible?
Protecting our data.
Yeah. I, Actually, that's a simple explanation, but good. So for a proper definition, we'd be say that cloud security refers to practices, technologies, and controls designed to protect our cloud-based data, applications, and infrastructure from cyber threats, unauthorized access, and damage. So it's just protecting the data which we upload into and our applications which we deploy in the cloud, and also the infrastructure which we use from the unauthorized access, hackers, or harmful malwares which attacks the cloud or our data. So these unauthorized access should be prevented. And we also know that, especially we have learned more about IAM, which is identity and access management. In identity and access management, its major feature is about authorization. So that ensures cloud security. So in the later sessions, we will be seeing the AWS cloud services which are based on cloud securities in detail. So at that time, we will be looking at IAM. So the cloud security also ensures confidentiality, integrity, and availability. Confidentiality means that it ensures the security for the user in cloud, and also that the data they upload is preserved properly and gives a trust to the user. Only if they have the proper trust that the cloud provider could be safe, then the people would be coming up and using the cloud platforms. To manage large applications such as Netflix and other important cyber applications, we definitely need a proper cloud-based security So only then those data should be preserved or saved. Or else it's easy for hackers or bad guys to just steal them off their own. So we'd always hear this shared responsibility model, and that's the basic principle in cloud. So shared responsible model just means the security in cloud is not just relying on cloud, or it's not just relied on the user or customer. It's relied on both the people. The shared responsibility model just means that in AWS, the responsibility in cloud is shared between the customer or the user and the cloud too. So the responsibility is shared between both of them. So how is it shared, and what are the roles of each of them? So AWS looks after the security in the cloud. That is, sorry, AWS just looks at the security of the cloud, and the user or customer just looks after their security in the cloud. So the user is responsibility for their security in the cloud while they are using it. But AWS is of the cloud and the infrastructure which they provide. So how this works? AWS just provides network, visualization layer, and data centers. And any theft or any problems in those data centers, visualization layer, the AWS is responsibility for that, and they'd be taking care of it. But in the user end or our customer end, the operating system, application, and the data which we upload, that's our responsibility. It's our data, and we are responsible for that. So AWS is not responsible for our things. So it's shared mutually, and this is how the AWS works efficiently as a shared responsibility model. Then importance of cloud security. Why do you think cloud security is important in these days? So it's just simple. Without cloud security, nobody would be willing to upload their data in cloud. Just take an example. You're having your phone, private phone, and you're having photos with which is of yourselves, your friends, and all. But if you're uploading those photos in cloud and you think that it's not secure, will you be coming forward to upload it? No, right? Only if it's secure and you know that no others can steal your data or information which you upload, only then you will be coming up to use that. So it's really important to have cloud security to ensure better usage. So why is it important? We'll be. Am I audible?
Yeah, Jefferson, you're audible.
Hello? No. So the importance of cloud security we'll be seeing one by one. So data protection. Data are the important things. Anything we upload in the cloud is mostly data, even our photos, pictures, and data are personal details too. So data protection is really necessary in cloud. So protecting our data is a key feature in cloud security. And business continuity. We know that it's not nothing is not inevitable. So it's easy that we'll be getting natural disasters, and there will be cyber attacks and several other issues which may lead for our data to get corrupted or affected. So we need to ensure that this data will be coming back, or we'll be getting back that data in safe hand so that we could use it again. So business continuity just means that even if those hardships which we face occurs, we'd be having a continuity in using those resources again. So that's why cloud security is important, and business continuity is a important feature in cloud security. Rame I explained previously in shared responsibility model or in the importance of cloud security. Do you have any doubts? You're asking it in comment section. Do you have doubts?
வந்து வந்து போறா அவ சந்தனத்தில் செஞ்சு வச்ச தேடா என்னுடைய கதை ரொம்ப பதிலா.
Hello, am I audible?
Yes.
Yeah, you're
Can you hear me?
audible. Yeah.
So, then compliance with regulations. This is the other important feature of cloud security. It provides us compliance with regulations and to protect us from cyber threat mitigation. So, of course, we'd be having these hackers and people who would be trying to steal our data. So, cloud security is important feature so that we'd be free of this such cyber threat mitigations and we'd be free to use our data in our day-to-day life. The other feature of importance of cloud security is building customer trust. As I mentioned earlier, only if you believe that the cloud provider is safe and you could upload your data and your informations in cloud, only if you have that trust, you'd be using that often. So, building a customer trust is an important aspect of cloud security. So we then now we'll be looking at the traditional security approaches as well as the cloud-based security approaches. As I said earlier, we'll be looking at the traditional security approaches and its limitations and how the limitations are overcome in the cloud-based security approaches. So the traditional security approaches, the first one is perimeter-based security. In Max, we'd be about perimeter. Perimeter just means the outer boundary. So we'd be having a outer boundary or a layer of protection, and the any type of unauthorized access or any type of cyber attacks would not happen beyond that boundary. So it is a boundary level security, which is also mentioned here as per the name suggests, perimeter-based security. So that's what just perimeter-based security mean in traditional security approaches. And the next two important points are antivirus security. Antivirus just means that it is a software that is used to keep us away from the virus attacks and protect our system. Antivirus is a software which we often get when we get a new system, PC or anything. Only because we can only then we'll be prevented from malware attacks or virus attacks, which can happen in any way while sharing our data or logging into new applications. And endpoint security just means we'd be having our end devices, which are our laptops, mobile phones. We have learned about this in our Cisco courses lately. Those are the end devices in our system. So these end devices also need security so that our data or access would not go in hands of people who actually don't need access to. So endpoint security at the end level is also an important feature. Then we'll be looking at access control mechanism. Access control mechanism just means that only due to this mechanism, we get access only specific people who are capable of getting into, or the people who need access to can get into this. Not everyone can get access into it easily. Only the people who are able to get access into can get into this. Then physical security. Physical security just means we'll be having servers and data centers. We have physical servers, right? We need to protect that physical devices too, so that those our data are not harmed. So physical security is also an traditional approach in cloud security. Network segmentation is the next point. Network segmentation just means splitting up the data into segments, and segmentation ensures that in each segment the security is provided individually so that it's hard to affect when than it's in a whole, because if it's in a whole, even if a single corruption occurs, the whole data will be affected. But in network segmentation, we'll be having segmented form so that even if one segment gets affected, the other segments are still protected. In on-premise monitoring, we'd be monitoring our data and cloud cloud platform in on-premise by setting up virtual servers. So we are having major three limitations in this traditional security approaches. Those three limitations are we have limited scalability, which we earlier saw on our cloud platform. So it is just traditional, right? So we'll be not having or will not be able to keep up with the day-to-day demand. So the scalability is of course limited. Lack of cloud compatibility. Traditional approach of course doesn't have cloud compatibility. Reactive nature just means that it reacts to the problem after it occurred rather than preventing the problem before it's occurring. Are you clear about it? Do you have any doubt? Should I explain any specific points in this? Do you have any doubt? Okay, I'll continue. So cloud-based security approach. So now we are going to look about the cloud-based security approaches. So data encryption. The first point is data encryption. Data encryption is the process of converting plain text into unreadable format called ciphertext. We know that in cryptocurrency and all, we'll be having keys so that our data are converted into unreadable data, and so that not an unauthorized person will not have an access to our data. Only we can just use our keys to convert it into readable data and then use our data again. So this ensures that our data is of course protected and remains safe. This transformation is done using cryptographic algorithms to protect the data from unauthorized access. So the next point is cloud security posture management. It refers to the practice of continuously monitoring and identifying and remediating risks or misconfigurations in cloud environment. So we keep a continuous check in our about our cloud access, and we keep an we continuously monitor our data so that it doesn't get stolen or damaged. So the next point is zero trust architecture. Zero trust architecture is a cyber security framework, which means that never trust and always verify. This is just the motto of zero trust architecture. So it assumes that anything which we log into or which we access can cause a threat, so that it will always ask for an authentication or verification. Only then we'd be able to log into it. So that's how the zero trust architecture works. Then identity and access management, which is IAM, which we already know. So it just provides authentication and verifications so that we could only then use cloud platform efficiently. So identity and access management is a key feature in cloud, so that a cloud engineer could give an IAM user ID, so that only limited policies the user will have access to. The next point is cloud workload protection platforms. So cloud workload protection platforms are security solutions designed to protect workloads in modern hybrid and multi-cloud environment. So they keep a track on workloads, and it's especially focused on hybrid cloud platform. So these are the cloud-based security approach, and we'll be moving into common cloud security threats. So, are you having any doubt so far?
Bro, can you please tell about authentication?
Okay. Can you repeat this? Hello? Hello? Did you just ask authentication? So, authentication just means that it's a process of verifying the identity of user, so that only the user who can get into the platform which is necessary. not everyone can get into. We'd be having a verification process. Only with the verification process we can get into the cloud platform.
Okay, Tapan.
So we'll be looking at the common cloud security threats. So these are the threats from which we should protect our cloud platform. So this is why cloud security is necessary. So first one is data breach. Data breaches just means that when a sensitive, confidential, or otherwise protected data is accessed, stolen, or exposed by unauthorized individuals. It's data breaches. Okay. So it can result in our loss of data, and our private data could be spread worldwide. So that's how we can also see that important documents and government secrets have been leaked at times due to cyber bullies who work on it. So the next point is insider threats. Even in the organizations which we work, we'd be having co-workers and people who work with us who can accidentally or purposely harm our cloud platform or our resources. So this could be prone to security risks too. So to overcome this, we need cloud security, of course. Then we'll be looking at DDoS attack. The DDoS attack just means distributed denial of services. So we know that DOS attack just means denial of services. In DDoS attack, it's just large amount of people, which is distributed amount of people working on to a certain server, so that it causes internet trafficking and malfunctioning of the server. So how this works would be in just three steps. How first they would be creating a botnet. After the botnet creation, they would be flooding with the traffic, and then the service will be disrupted. So first the attacker will infect the end devices like computers or IoT devices with a malware, and then they will be turning them into bots of their need. Then these infected devices, or these collectively called as botnets, will be attacking the desired server in a large amount. So the attacker will be sending an overwhelming volume of requests or data packets, so that the server will be coming down and affected. So users are unable to access the services due to this, and this should be prevented too. SQL injection is on database management system, and database SQL commands are often used to look after our data. So that the data are present in a structured manner. So it's easy to make this because SQL codes are easy to modify by hackers. They'd be just injecting a malware type of SQL code, so that the entire data would be in their control, and they could get the whole access of the SQL codes. So of course our data would be in this condition. And account hijacking just means taking control over our logging in account, let it be email account or our social media account or even our cloud account. Malware attacks, we know that while clicking into links accidentally, we often encounter malwares. So to prevent this, as I said earlier, we use antivirus. So a common type of malware which we often say our system has been affected by virus, it's a malware. So insecure APIs. So now we'll be looking at how insecure APIs are a threat in cloud computing. So APIs just means application programming interface. And insecure APIs refers to vulnerabilities in application programming interface that allow unauthorized access, data breaches, or manipulation of sensitive information. So, of course, APIs are responsible for communication between software system. So, using this APIs only will be communicating between the software. So if hacker or the who wants access over it to get entire control over the applications or the web server. So data loss. Data loss is as the name suggests, it's just loss of our data. Then we'll be looking at the cloud services, which is based on cloud security. So some of the cloud services which we are going to look today are IAM, AWS Web Application Firewall, AWS Shield, AWS Key Management Service, AWS Guard Duty, and also. So IAM, as we know already, it stands for Identity and Access Management. So if you're just taking an multinational company, and if you're working there as a cloud engineer, our role would be we'd be having an root user account. So, and cloud engineer would be having a root user account, and the root user is supposed to provide the developer or an individual user an IAM account. So if user needs a specific IAM account, he can create an IAM account of his own and only give the policies which are the limitation. He can limit the amount of policies he can access to. So in case of IAM, we can give the permissions of our own. That is the cloud engineer would be having the JavaScript object notation, which is called JSON. This IAM works on least privilege principle, as we know. In case of groups, here we saw that a single user is given an IAM account. In case of groups, we'd be having developer, programmer, and certain people in our getting the permissions and policies. And when a person from the certain groups comes for an access through it, as a cloud engineer, we could give an access to this group so that he'd be get access to our IAM account. Then roles are also assigned in IAM. And we know that IAM works on the basis of multi-factor authentication. So we'd be having authentication in various levels so that our data is protected. So next we'll be looking at AWS Web Application Firewall. Managed service that helps consume excessive resources on web applications based on ops, and we control the bots in using this service. And the other advantage would be it is application firewall while using the other services too. And we have ACLs, which mean access control list, which means we'd be having, and the access would be controlled in a web application. Rule prioritization means we can prioritize our rules so that a certain set of rules would be having higher priority, and that's just based on our own needs too. The next service which we are going to look is AWS Shield. AWS Shield is a managed DDoS protection service that safeguards application running on AWS. It provides detection and mitigation capabilities to protect against network and application layer attacks, ensuring that the availability and reliability of our application. So, AWS Shield is another service which is mainly focused on protecting us from DDoS attacks. So it just acts as a shield against the unauthorized users or threats, which we saw earlier. So the important features are in AWS shielding. We'll be having AWS standard shield and we'll be having AWS Shield Advanced. The standard shield is free and the AWS Shield Advanced is paid. And as we saw earlier in AWS Shield 2, we'd be having it integrated with several AWS services. And we'd be also having real-time threat mitigation. So we, which we saw earlier in detail. AWS Key Management Services. AWS Key Management Service, which is in short from KMS, and is a fully managed encryption service that enables you to create, manage, and control cryptographic keys to secure your data and application. As we saw earlier, we create cryptographic keys. These keys, we need an access to these keys, only then we'd be able to access the data. So even when we did our tasks in our 30-day cloud challenge, we'd have used this AWS key management for security purposes. So the important features of AWS key management services are key management, key rotation, audit and monitoring, data protection, and regional isolation. Regional isolation just means the keys are just new for every global region. It's not common to every global region. And the next AWS service which we are going to look at is AWS Guard Duty. AWS Guard Duty is a fully managed threat detection service that can continuously monitor your AWS accounts, workloads, and data for malicious activities, unauthorized behavior. So it is also leveraged or combined with machine learning, anomaly detection, and integrated threat intelligence to identify and get potential security threats. So how it works is based on machine learning and anomaly detection. Just means that it would be having an overall check on our day-to-day activities. For example, if you are having an daily average billing of $30 billing and reach just a change from our day-to-day life, and AWS Guard Duty takes care of it. And we'd be aware of our change in our rate of billing. So that's how AWS Guard Duty secures our data and keeps an overall monitor of our accounts and workloads. So it detects the threat, and also, as I said earlier, it is based on machine learning and also helps in actionable findings. Then best practices. So this is the last topic which we are going to cover. So we have seen the saw what are the cloud services that are present in AWS. So what are the best practices? General best practices would be enabling multi-factor authentication, which is MFA, and data encryption, I said earlier, so that our data will be preserved. And we can also, this data encryption should be ensured while the data is at rest and while it is in transmitting state, or when we are transmitting our data from one system to other. And also perform regular audits and vulnerability scans so that we could make sure that our data are safe in our day-to-day life. And backing up critical data. We'll be having critical data which is so sensitive, and we need to take care of it. So backing up those data daily can prevent from security risks. So these are the general best practices. Specifically at AWS best specific practices, we can say that we can use AWS organization for cloud management. Using AWS organization, it is easy for us to log in and use our account in a safe manner, and also it ensures easy policy, security control, and hierarchical structure, and even better billing. So implementing security groups and NACLs. NACLs just means network access control list, and implementing security groups is another important factor, because security groups acts as a virtual firewall and protect our instances in cloud platform. So the last point is we can monitor our cloud with two important services in AWS, which is provided: CloudWatch and CloudTrail. CloudTrail has its own advantage such as API activity, logging, monitoring, are such important activities in cloud. So we can keep an overall keep an eye on our day-to-day activities in cloud and secure our data and files which we have uploaded in our cloud. That's all. So that's all. Do you have any doubts? Hello? Are you clear with the topics? Should I explain any specific services or topics again? Hello? Do you have any doubts?
Tech Army, do you have any doubt? If you have any doubt, unmute yourself and you can ask. Tech Army.
So thank you everyone. Thank you for cooperating.
Yeah, thank you, Jefferson, for your beautiful session. We learned something new today. I hope it will help all others who are like learning for their practitioner exam. Thank you, Jefferson.
Thank you. Thank you.